All right, so welcome back to OneClass. My name is Joey. I'm going to be your math teacher for this session. If you're tuning in for the first time, thank you so much for watching. What we're doing here at OneClass is that we are providing unique online lessons and basically live streams and videos of teachers generating solutions for our students at home. We know due to the COVID-19 situation, there are a lot of school closures and schools basically closing indefinitely. So what we're doing here is OneClass, we're trying to keep you on top of your studies, and we are basically making these videos for you, for us teachers at OneClass, to basically teach you concepts that you most likely will learn at school. And these contain subjects in the secondary school level and the university and the college level in both the subjects of mathematics and also in chemistry as well. So a little bit about myself. My name is Joey. I'm currently a secondary school educator in Ontario, and my teachable subjects are chemistry and music. However, I am planning to get my teachable in math further down the road once school opens up again. So with that being said, I did stream a bit earlier, and we did problems with kind of grade 9 math and grade 8 to 9 math in terms of pre-algebra, algebra 1, and geometry. So what we're going to do today is for the next hour, I picked problems that you would typically find in algebra 2 or pre-calculus situations. So kind of grade 11 and grade 12 math here. So without further ado, let's get started on these problems for today. All right, so we have here, it says, according to the fundamental theorem of algebra, which polynomial function has exactly 11 roots? So we're looking for a polynomial function that has 11 roots. So polynomial. So when we say it has 11 roots, we can also say it has 11 x-intercepts or 11 solutions to the polynomial. So let's look at A here. And A here is x minus 2, and then x plus 2 to the power of 11 here. And basically, when we have this polynomial function, we can basically say that the maximum amount of the maximum amount of roots that exist in a polynomial function is basically the highest degree. So when we're multiplying exponents, remember we have this. You can think of this as x minus 2 has a degree of 1 here. When we multiply 1 by 11 here, we're going to add our exponents, right? Every time we're multiplying exponents, we can simply just add the exponent numbers here. So we have imaginary 1 here. You can think of it this is that. So we have 1 plus 11 here, which means we have here, this would be 12 roots, right? Or 12, the 12 is the highest degree here. So we can say maybe I'll write down 12th degree here. This is the 12th degree, which means we have, if we're in the 12th degree, this means we have 12 roots in our solution, right? So we have 12 solutions, or we have 12 roots here, or 12 roots here. We're looking for 11 roots. So this here is the incorrect answer. So A would not be the correct answer here. We can look at B here. B would state that we have x, this is x cubed plus 3x squared plus 3x squared plus 2 to the power of 4 here. And then whenever we're taking anything to the power of 4, again, we have an exponent within an exponent. We're going to multiply our exponents, right? So let's look at it within the bracket here. We have a cubic function, x cubed plus 3x squared plus 2 here, which means the highest degree we can ever get, it would be a x cubed here to the power of 4. Whenever, again, taking the exponent by the exponent, we are multiplying exponents, right? So 3 times 4 here would give me 12 again. And again, we would have the 12th degree. So in the 12th degree here, this would be 12 roots again. So this here would not be our solution here because we are looking for 11 roots, right? So this here is in the incorrect solution here. Let's look at C. C would give us x squared. So it's x squared plus 1 cubed times x to the 5 plus 9x cubed plus 4x squared plus 16x, right? So looking at this function here, we have x squared plus 1 cubed, right? In this case, we can rewrite this as, okay, I have the exponent with the exponent, I'm multiplying exponents. So x squared times 3. So 2 times 3 here would give me an exponent of 6 here in this case. And then 6 here I'm going to multiply that. If I'm multiplying exponents here, I'm going to add exponents, right? Exponent with an exponent is multiply. Multiplying exponents would just simply add my exponents, right? And this here is a quintive function. I have something to the power of 5 here. So 5 here, I'm going to add 6 here, which will give me the 11th degree, right? So this will give me the 11th degree, which would equal my 11 roots. So C here will be our correct answer for this solution. So C here is correct. I'm going to just check D for you as well to ensure that this is the correct answer. D here I have, this is 15x to the 9 plus 47x to the 7 plus x cubed plus 5 times x minus 3 here. And as you can see, the highest degree in this first term here is 9, and this degree here is 1, right? So 9 plus 1 here would give me a 10th degree. 10th degree, which would give me actually 10 roots here. So in this case, this would give me 12 roots, this would be 10 roots, and finally C would give me 11 roots here. So again, this here means that C here is our correct answer because it gives us 11 roots. So this here is our correct answer. C here is our correct answer. And as you can see, the solution also says option C is our correct answer. And as I can, again, stated, a fundamental theorem of algebra states that a polynomial of degree n has n roots counting multiplicity, right? So we're counting the repetition of roots here. So A has 12 roots, like we said here. B also has 12 roots, like we said here. C has 11 roots. And finally, D here would have 10. So this solution here is correct. So solution is correct. Good analysis here. So the solution here is correct.